Hello, I'm ETarte, math teacher. This is the seventh in a series of videos in which I show myself tutoring fifth grader Nick, and in many cases trying to help him to discover something about math. Nick is studying fractions, and I wanted to give him an enrichment exercise that would go a little bit beyond what he is having in math class. I hope that you will have the patience to watch this entire video, because I think your patience will pay off when you see Nick discover what I wanted him to discover. I began by having him write the word fraction like this. This is my writing, not his. And then we singled out the letters R-A-T-I-O and formed the new word ratio, a word with which he was not familiar. And I told him that ratio actually means the same as fraction, and I presented him with a typical ratio problem. And if you want to, I suggest that you have paper and a pencil handy and participate as we go along. We're talking about a birthday party, and at that party, the ratio of girls to boys is 3 to 2. Ratios are often written, we often say them with the word 2, but we use a colon often, which is one dot above the other, 3 to 2. What that means is that for every 3 girls at the party, there are 2 boys at the party. But it's a large party. There are 20 kids in all. And my questions are, how many girls are there? And how many boys? I wonder if you understand what the situation is, and I want to see if you can figure it out. The ratio of girls to boys is 3 to 2. That means you could match them up. For 3 girls, there would be two boys.
Oh, but that's very important.
Yes, it is.
All right.
Now, 3 girls and 2 boys makes how many people altogether?
5.
Okay, but there are more than 5 people at this party. There are 20 kids at the party.
Oh, so for every 3 girls, there's 2 boys.
Yes.
So
here's what Nick's writing: 3, 2, 3, 2, 3, 2, 3, 2.
I think I know what I'm doing. All right, well, that's 20 right there. But now...
You're right, it is.
But
How do you know so? Tell me how you know that. Tell me how you got that to be 20.
Because 3 plus 2 is 5, and 5, 10, 15, 20.
That's right.
And now you just set it out, and now there's 12 girls.
Yes.
And there's 8 boys.
That's right. Very good. Okay, now here's something I often do in situations like this. I give you a similar problem, but with bigger numbers. Let's suppose a kid has a very large marble collection, and the only kind of marbles he likes are red marbles and green marbles. So that's what he collects.
All right.
And his ratio,
His fraction,
right, of reds to greens,
right,
is 4 to 3.
4 to 3, right.
Madre, that means, I'll start the sentence and ask you to finish it. That
yeah,
means for,
I know what's your meaning. Yeah.
okay, what does it mean?
That means for every 4 reds, you get 3 greens.
That's right. Okay. But he has a large collection. He has,
Yeah, how many does he
he has
collect?
he has 182 marbles in all.
182 marbles. What? Man.
And what do you think I want to know?
What, like, how much each person get, like
This is
red,
about
how
mar-
much, yeah, how much red and green?
How many red marbles does he have, and how many green marbles does he have? That's right. Now I'm curious as to whether you're going to do something like this. If you do, it's going to be very tedious.
Yeah.
You know what tedious means?
No, but I think I know what it is.
It's going to be,
It's like you keep
very-
on repeating it.
it's very boring,
It's
and
long.
you'll have to do a lot, and
Yeah.
it'll be hard to keep track. So
let's
this is
try,
why I want you to look for a shortcut.
let's try a new method here.
Yes.
So let's just. I could actually try to do it in my head, but that wouldn't.
In this problem, there is actually a hidden number. There, and you said the hidden number at one point. Do you know, it's an important hidden number with these 3s and 2s.
20.
Well, that number is not hidden because
Oh.
I gave you that number.
5.
5, that's right. Hidden number is 5.
And that would be 7.
Yes, the hidden number in this problem, it's actually the key number
Mm-hmm.
to solving it. I'll call it the key number, is 7.
And 182 divided by 7.
Try that and see what happens.
What 182 divided by?
Yes.
Right.
You wrote the number incorrectly there.
Oh.
2, that's right.
Alright, so.
Okay, so
26.
what does that 26 mean? That's an important number toward working the problem. What does it mean? What are you going to do with it?
26 greens?
No.
Wait, no.
Let's go back to this problem. What's the hidden number in this problem?
5.
Okay, now what can you do with the 5 in this problem? And a number that I gave you.
Couldn't you add it?
No, you did something. Actually, you did this really fast in your head. Maybe you didn't realize you did it.
I realized what these numbers meant.
How much is that?
5.
And how much is that?
5, 10, 15, 20.
Okay, how many 5s is that?
4.
Yes. Can I write 5 4s make
20.
the given number 20?
Yeah.
Okay, well, what about this?
Would you do something with the 4 3s? Or the 26?
You do something with the 26 and the 4 and the 3.
Man.
It's confusing, isn't it?
Yeah.
It's hard to compare these. So we have another hidden number 4. What is? How do we have a hidden number 4 here?
Because 3 plus 1 equals 4.
I'm trying to show you the hidden number 4.
Because there's 4 of these things.
Yes, 4 groups.
Yeah.
4 groups.
Yep. And now would we need to know the number each side of these,
Right.
like 1, 2, 3, 4.
Right. And notice, since there are 4 groups, there are 4 threes.
There's 4 twos.
That's,
And that would be 8.
that's right. 4 threes and 4 twos. And how much is 4 threes?
12.
Okay. That's the number of girls.
Mm-hmm.
And how much is 4 twos?
8.
Yes. And that's the number of boys. Okay, now those are the details of this problem. Can you transfer those details to this problem with the bigger numbers? And you've worked it more than about halfway, or maybe even more than halfway.
Oh, 26 of those 4 threes.
Yes,
So,
I think you got it.
So like this.
Are you going to write all 26 of them?
Mm-hmm.
Oh, well, you could do that, but that's what I call tedious. This is where to look for a shortcut where you won't have to write all 26 groups.
What did you do?
It's a shortcut that you've studied. It's an operation in math which
couldn't you
is
do
a
like
shortcut.
half, like 13?
Well, yes, but I want you to do an even better shortcut.
Have I learned it?
Yes, you have. You have learned an operation, and you've been doing the operation a lot, which is a shortcut for addition. A shortcut where you add the same number over and over.
You multiply.
Yes, multiplication is a shortcut.
So
to
could
addition.
you do 7 times 26?
7 times 26 will give you the 182. I mean, and you already know about the 182. You want the number of reds
And the number of greens.
and also the number of greens. And there are
Man.
4 reds for every 3 greens. So if you write out all of these, how many 4s would you have?
26.
Yes, you have 26 4s.
I know this.
Do it.
Now I know it.
Do it.
But
But don't write all 4s.
yeah.
Use the shortcut.
$104 reds
Yes.
and and 78 greens.
That is right, but I want you to prove that it's right in a very simple way. Just add these 2 numbers and see what
it
they
equals
get.
182.
Are you sure about that?
Pretty sure.
If they do,
It was 12 and 3. Wait, no.
you wrote 20. Did you think that was 28? It's 78.
Alright.
You read it as a 2 because you did it so fast.
8 and 4 is 12. 1 and 7 is 8. Yep.
That is very strong evidence that you've done it correctly. Okay. Well, I then went over one more example with Nick, and I won't show that to you here because it might make the video too long. But at the end of the lesson, here's what I said to Nick. You have made a discovery, and I guided you to it. That's really the best thing you can do in studying things. It's what a scientist does, trying to discover things. You've discovered something that was based on things you already knew, but it was something new for you.
And more challenging.
Yes, and that's about the best way there is to use your brain. So congratulations.
Thank you.
Thank you for watching.